Let us continue with exercise 8D trigonometry question number 24. We have to prove the left hand side equal to right hand side. Here we have tan theta by sec theta minus 1 plus tan theta by sec theta plus 1. We have to prove that it is equal to 2 cosec theta. Since there is no square, we cannot apply identity, but we have plus and fraction, so we better find the LCM. Here we have 1 with minus, 1 with plus. Both are different. We can take both as LCM. Then if you look, tan theta are common. So we can take common tan theta outside. Inside we are left with 1 by sec theta minus 1. Then this side also 1 by sec theta plus 1. Both are different. We can take both as LCM. If you divide this one with LCM, we are left with plus. So sec theta plus 1 into 1 will be sec theta plus 1. Then if you divide this one here, we are left with minus. Sec theta minus 1 into 1 will be sec theta minus 1. So here inside bracket you have plus 1 minus 1. We can cancel. Then sec theta plus sec theta, we have 2 sec theta. Then in the denominator, we can apply a minus b, a plus b, which is a square minus b square. So 1 into 1, 1. If we check from identity, sec square theta minus 1 will be tan square theta. Here we have 1 tan, here we have 2 tan. So one of it we can cancel. We are left with 2 sec theta by tan theta. But in the right hand side, we want cosec. So change everything to sine and cos. Sec, we know it is 1 by cos theta. Tan theta, we know sine theta by cos theta. Cos theta, we can divide because both are in the denominator. We are left with 1 by sine theta, which is equal to cosec theta equal to right hand side. Next, we move to 24 number 2. There again we have cot theta by cosec theta plus 1 plus cosec theta by cot theta. We have to get only 2 sec theta. Here also no square, but we have fraction with plus. So let's take LCM. Both the denominator are same. We have to take them both as LCM. If we take this denominator, we divide here. We are left only with cot theta. So cot theta into cot theta, we are left cot square theta. Cot theta divide LCM, we are left with cosec theta plus 1. If we compare this one with the numerator, they are same. So we can write whole square because we have to multiply them. Then now here cosec theta plus 1 we can apply formula. The rest we write first the same. We use formula a plus b whole square. So it will become cosec square theta plus 2 cosec theta plus 1. Then cot theta, in the right hand side we want sec theta. So cot square theta, we can apply identity. It is cosec square theta minus 1. Then now we have plus 1 minus 1 we can cancel. Then cosec square theta, both plus, we can plus them. We have 2 cosec theta. Then here we have cosec theta, cosec square, 2, 2. We can take common 2 cosec theta. Here we have 2 of them. So 1 is outside, 1 we put outside. This one we only take everything, so we are left with 1. So this one and this one get cancelled. We want only sec theta, so we can apply to sine and cos. Using identity, cosec equal 1 by sine, cot is cos by sine. So sine theta and sine theta both in the denominator, we can cancel. 1 by cos theta, which is equal to sec theta equal to right hand side. Then we go on to question number 25. Here also we have no square, but we have fraction with plus sign. So same way we'll continue to find LCM. If we look at denominator, 1 plus sign, 1 minus sign. We have same quantity but different sign. So we have to take them both as LCM. Then if we divide the LCM by denominator, here we have plus. So this one get cancelled. We are left with this minus sine theta minus cos. If we compare with numerator, it is the same. So if we multiply this 2, since they are same, we can write whole square. Here also, if we check the denominator and LCM, so this one is same. We are left with sine theta plus cos theta. This one we have to multiply to numerator. But if you compare, they are same. So that means we can write sin theta plus cos theta whole square. Now we can apply this side a minus b whole square, this side a plus b whole square. Our a is sin theta, b cos theta. So it will come a square plus b square minus 2ab for the first part. The second part will be a square plus b square plus 2ab. Okay. Then if we compare both sides, 2 sin theta cos theta plus 2 sin theta cos theta minus. So we can cancel. Then using identity, sin square theta plus cos square theta, we have 1. This side also, sin square theta plus cos square theta equal 1. So 1 plus 1 will be 2. But when we look at the denominator, we have 1 plus 1 minus. So we can use a plus b, a minus b, which is equal to a square minus b square. If we check at the right hand side, we don't want cos, we want only sine. So in place of cos, we can replace identity. Sine that it be there, minus in place of cos, with using identity, cos square equal 1 minus sine square theta. So minus into plus, minus, minus to minus, plus. So sine square plus sine square, we get 2 sine square minus 1, which is equal to right hand side. We will move on to the next question, 25 2. Here also similarly, we have the ratio of sine minus cos, sine plus cos. We want to get 2 sec theta by tan square theta minus 1. Here also we don't have square, so we cannot apply identity. That means since we have fraction with plus, let us find LCM. Look at the denominator, the quantity are same but the sign are different, so we have to take both as the LCM. Then compare the denominator with LCM. This minus is removed, we are left with plus. If we compare this one with numerator, they are same. Since we have to multiply, we can write whole square. Then this side also we have it plus. If we compare with numerator, we are left with minus. If you compare this one with numerator, they are same. Since we have to multiply, we can write square. Same way, the first part we can apply a plus b whole square. The second part we can apply a minus b whole square. A is sine, b is cos. So it becomes a square plus b square plus 2ab. Here also a square plus b square minus 2ab. Then minus 2 sin theta cos theta. Here plus sin 2 sin theta cos theta. We can cancel. Using identity, sine square plus cos square equal 1. Here also sine square plus cos square equal 1. Numerator is left with 1 plus 1. Denominator, we have a minus b, a plus b. We can apply the formula a square minus b square. Then if we check the right hand side, we don't want sine, we don't want cos, we want tan. So what to do? We know from the relation that tan equals sine by cos. So since in the right hand side we want tan, that means what to do? We can divide both numerator and denominator by cos theta. So in that case, we can write 2 by cos theta sine square by cos square minus cos square by cos square. So 1 by cos square here become sec square theta according to the relation. Sine by cos equal to tan square theta. Cos divide cos, we are left with 1, which is equal to right hand side. Then question 26, we have numerator cos and sine, denominator also cos and sine. But numerator we have cubed, cos cubed plus sine cubed, cos cubed minus sine cubed. Here we do have the formula a cubed plus b cubed from algebra, a cubed minus b cubed from algebra. So before we find LCM, let us use that formula. I hope you know the formula. A plus b whole cube. We use the third form, it will be a plus b, then a square minus ab plus b square. Then for a cubed minus b cubed, again if we use the third form, it will be equal to a plus b, a minus b, then this side will be a square plus ab plus b square. So let's use that, but in place of a we have to write sine, in place of b we have to write cos. Okay, so here it comes cos. For the first part, a plus b whole a square minus ab plus b square. Then denominator, let it be the same. Then for the second part also, a minus b, a square plus ab plus b square by this one. So if you compare numerator and denominator, the first bracket can cancel, second part also get cancel. Then here we have cos square plus sine square, identity equal 1. So 1 minus sine theta cos theta. Second part also cos square plus sine square, we get 1 equal 1 plus cos theta sine theta. Then if we compare from both, minus sine theta cos theta plus cos theta sine theta, we can cancel. So we are left with 1 plus 1, which is equal to 2, equal to right hand side. Then we move on to question number 27. We have sine theta by sec theta plus tan theta minus 1 plus cos theta there. To take LCM also, all are different. Then also at the same time we have three quantities, but in the right hand side we want only one. Well, when we have so many things, then answer is only one. What to do? We convert everything to sine and cos. So this one is sine, let it be. Sec theta, we know it is 1 by cos. Tan theta, we know it is sine by cos. Then 1. Then cosec, we know 1 by sine. Then cot, we have cos by sine minus 1. So numerator, let it be there. Denominator, we take LCM. So cos theta 1. LCM will be cos theta. So cos theta and denominator it is same. So 1 plus sine. But here we have 1. So 1 divide cos will be cos. So cos into 1 cos theta. Here also we have sine and 1. So LCM will be sine. Denominator and LCM are same, so for these two there is no changes. But here 1 divide sine will be sine into 1 will be sine theta. So the sine theta, it can go together with cos also it can go with this. Then if we look at the denominator, we have 1 plus sine theta minus cos theta. Here also we have minus, so if I take common this minus, then it will become sine theta will become plus, then minus to plus will become minus. So if you check from both sides, now we get 1 plus, as to say a plus b, a minus b. So now we can take their LCM. So both are different because sine theta minus cos, here also sine theta minus cos, only different is in sign. Here we have minus, here we have plus. So if we take LCM, we have to take them both. Then if suppose we divide, it will cross, okay? This one will multiply this side, this one will multiply this side. And sine theta and cos theta, they are common. So we can take common. So after we divide by denominator, the LCM, and multiply numerator, we see we get this one. So minus cos and plus cos we can cancel, minus sine and plus sine we can cancel. So 1 plus 1 will be 2 sine theta cos theta. Then down we can apply a plus b, a minus b. Our b is sine theta minus cos theta. So it will be a square minus b square. Then numerator we cannot do anything, let it be there. Here 1 into 1 will be 1. Now here we can apply a minus b whole square. So it will be a square plus b square minus 2ab. Then numerator, let it be there. Here 1. Then into here we know sine square plus cos square, from identity it will be equal to 1. So minus into plus will be plus. Minus. Then minus into minus here will become plus. So 1 minus 1 becomes 0. So we are left with 2 sine theta cos theta, 2 sine cos theta, sine theta cos theta, same quantity. So it will be equal to 1, which is equal to right hand side.